All right, welcome to lesson 4.2, constant rate of change tables. So we're going to focus on tables today. The objective for this lesson is I can determine if a table is proportional and find the constant of proportionality. Constant of proportionality is a new term to us, so we're going to go over some vocab real quick first. All right, so you're going to see a couple things. Constant rate of change, constant of proportionality, and the unit rate. All of these are the same for right now. So these are all interchangeable at the moment. So the rate of change just means how much y changes when x changes. How much the dependent variable changes when the independent variable changes. For example, if x is the number of tickets and y is the cost, the rate of change would be how much the cost increases when you add more tickets. Constant means that it stays the same. Constant, doesn't change. And proportional is when the rate of change is constant. And a lot of these words are overlapping. So the big idea is that, and you're not going to really see this until we get into the tables, but if the rate of change is constant, it stays the same, then it's proportional. If it's not the same, it's not proportional. So to find the constant rate of change, we use the letter m to represent that, because when you get into writing equations for things, you're going to see the letter m a lot. And we can find m by doing y divided by x, which is, so y divided by x. We're often going to represent it as a fraction to use to represent division, but these mean the same thing. All right, so let's figure out how we're applying all of these terms. Here we have a table where we're looking at sodas versus how much they cost. We've got one soda for $2.50, two sodas for $5, three sodas for $7.50, and four sodas for $10. We want to know, is it proportional? Is the cost going to be the same for a single soda no matter how many sodas you buy? To do that, we're going to have to divide y by x. First, we want to label our variables. Sodas is important, and I believe we talked about this in the pre-module review when we talked about how to identify variables. Cost is often the y variable. So here we have cost for our sodas, so that means that's going to be y, and sodas is going to be x. So if we're doing y divided by x, we're going to do the cost divided by the number of sodas. Here we have $2.50 divided by 1 for one soda. Grab your handy dandy calculator. This one's not too bad. 2.50 divided by, notice it gets rid of the 0. That's okay. It doesn't change our answer. 2.5. So we're paying $2.50 for one soda here. Okay, let's look at if we buy two sodas, our cost goes on top, so that's $5 divided by two sodas. And I'm just going to put in the 5 because the zeros don't matter. Divided by 2, 2.5. So again, if you buy two sodas, you're still paying $2.50 each soda. We have $7.50 for three sodas. We're going to divide. 7.5 divided by 3, 2.5. And lastly, we have $10 for four sodas. So we're going to do 10 divided by 4, 2.5. So, what the heck does that mean? We have to decide if it's proportional, yes or no. We have to look at our m, or our constant of proportionality. 2.5, 2.5, 2.5, 2.5. Remember earlier I said if it's constant or stays the same, notice these are all the same, then it's proportional. So yes, this is proportional. The relationship between the number of sodas you buy and how much you pay for it stays the same every time. The more sodas you buy, you're still paying $2.50 for each soda. All right, let's look at another example. Here we have time in hours, 3, 4, 7, and 13. Notice it's not counting evenly. It counts by 1, and then it adds 3, and then it adds 5, and that's okay. Sometimes tables are a little messy. And then we have the distance they're traveling in that amount of time. So in 3 hours, 165 miles, 4 hours, 220 miles, 7 hours, 385 miles, 13 hours, 767 miles. If you remember from the pre-module review, we talked about how time is almost always our x, and distance is almost always our y, or dependent variable. We're going to do the same thing. We're going to do y divided by x. So we're going to do our distance divided by our time. So our first set here, we have 165 miles in 3 hours. 165 divided by 3, we get 55. So there's our first m value. Next, we have 220 miles on top divided by 4 hours. 220 divided by 4, 55. So far, so good. These are proportional. Same. Next, we have 385 miles divided by 7 hours. 385 divided by 7, 55. It might be tempting to say, well, it's proportional. Come on, we've looked at all of these values. We get the same number. But it's important that you check every single one, because it could feel proportional up until the last minute. Lastly, we have 767 miles in 13 hours. 767 divided by 13. Oh, 59. So here we have 55, 55, 55, 59. If these are not all the same, then it is not proportional. We want to make sure we have the exact same number in our table for it to be proportional. Go ahead and jump into your practice. Let me know if you have questions.